are. Now, let me demonstrate side angle side, because I believe side is obvious. All right. If three sides of a triangle are congruent to three sides of another triangle, then those two triangles are congruent. However, side angle side, for some reason, has students make mistakes. All right. So when I say side angle side, I want you to think about this. I want you to think about a side, then an angle, then a side. All right. So the angle is between the what? The two sides. All right. The angle is between the two sides. That's what I need you to kind of remember when you're doing side angle side. So, for example, if I were to draw a triangle, and when I draw that triangle, all right, I'm now going to copy it. And as soon as I can show you, or as soon as I can demonstrate that this side is congruent to this side, and this side is congruent to this side, and then the included angle is congruent, now I can say those triangles are congruent by what? Side angle side. All right. If I show that all three sides are congruent, I don't need an angle. All right. So now if I say that, you would say that the triangles are now congruent by what? Okay. Now, once you prove that the triangles are congruent, you then can say that the corresponding parts of congruent triangles are congruent. All right, so you will be saying or writing CPCTC. All right, that means the corresponding parts of congruent triangles are congruent. So we've established those two blue triangles are congruent by what? Side, side, side. So how do I know that this angle is congruent to this angle now?
Because of side, side, side.
Because of corresponding parts of congruent triangles are congruent. How do I know that this angle is congruent to this angle up here? Because those are corresponding parts of congruent triangles. The corresponding parts are always what? Congruent. Once you prove three parts of the triangle are congruent, then the rest of the parts of the triangle are what? Congruent. That's what is meant by CPCTC. I get to the test sometimes and I still have people who don't understand that concept. Corresponding parts. That means this angle corresponding to that angle. Those corresponding parts, as long as the triangles are congruent, those parts are what? The reason I'm saying that multiple times because people aren't listening. You can understand this whole lesson if you understand that piece of information. Corresponding parts of congruent triangles are congruent. You first figure out the triangles are congruent using side, 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 or side angle side. And then you tell me the part that you're looking for is congruent because of this thing called CPCTC. That's it. That's how easy. All right. There's really nothing to it. All right. You first have to show the triangles are congruent. Once you show that the triangles are congruent, then their parts are congruent. All right. So let's see. All right. Everybody can write down question number 4. All right. Now, here we go. I have it right here. If you want to draw that figure real quick. And then we will try to prove that BC is congruent to DA. Now, when you're trying to prove that, you want to say, okay, what two triangles are congruent? And as soon as I say the triangles are congruent, then I can say those sides are congruent. All right, so let's give it a shot so I can demonstrate how really simple this is, but for some reason, people think it's difficult. So here we go. Let's put down the given.
Mhm.
All right. All right, anybody want to tell me? All right, now generally we mark when they tell us it's congruent. On the test, I will not have the things marked, but they went ahead and marked them for you. All right, so this is what we have. All right, super easy one to start out. All right, so those two parts. All right, so someone who's thinking can jump in, go.
Line AC is congruent to line CA.
You are amazing. AC, but we're gonna go ahead and say AC is congruent to AC, okay? All right, and that's what?
The-
Yeah, reflexive. That's all it is, guys. Reflexive property. All right. So now what?
we could say That
That what?
AC is congruent to AB.
Nope. Tell them.
Triangle ACB is.
Hold on a second. Triangle. A, C, what? ACD. Very good. Is congruent to triangle. Now you got to make sure you're correct. You went AC, correct? So let's see what she's doing here. All right, let's highlight this together. She went kind of like the hypotenuse and then the long leg, right? And then the short leg, correct? So what would that be now? It wasn't it, isn't it CAB? Everybody okay with that? That makes sense? All right. And then now that's just what? Say it. Yeah. Side, angle, side. The triangles are congruent by side, angle, side.
How is that given them?
I don't know what you mean. How is that not given? What is given?
Because BAC is angles.
All right. And now what? BC is congruent to DA by what? By what? CPCTC. I know it's not that hard, right? It's really not.
How did you just know that?
I don't know what you mean. How do I just know that?
Let's see.
Are the two triangles congruent?
Yes.
Then what's true about their corresponding parts? That's what that means. Corresponding parts of congruent triangles are congruent. I also know that angle B is congruent to what? Angle B is congruent to what? Angle D, because corresponding parts of congruent triangles are congruent. I also know that BCA is congruent to DAC. Why is that? Yeah, corresponding parts of congruent triangles are congruent. That's all I'm telling you. All right, prove the triangles are congruent, then you know all the parts are congruent. That's how simple that was. All right. Let's see what else we have. For number 5. All right, one is given. Bless you. Now let's go ahead and mark this figure. QR is congruent to what? SR. And ST is congruent to what?
QT.
Yeah,
QT.
all right. So obviously, again, yes, RT is congruent to RT. And we have what reason? Yeah, reflexive. And now we can say what? We are amazing. Triangle QRT is congruent to triangle SRT by,
CPVS.
say it. Yep, side, side, side. All right, they didn't ask for any of the corresponding parts. They just asked for the triangles being congruent. Yes, sir. Well, what would you want me to say? Why is that? Yes, because it's shared with both triangles. See, again, for every triangle, you have to show that 3 parts are congruent. All right, every triangle has 3 parts that must be congruent. If you can prove 3 parts are congruent, then the 2 triangles then are going to be what? They're going to be congruent. All right. Today we're learning specifically side, 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 and side, angle, side. Anybody have problems with number 5? All right, here we go. Be relatively easy. Okay, so that's what I have gathered from the information. All right. So now I need some help with the meaning of this. What does the meaning AC bisects BD? Go ahead, Whit.
Both lines meet up at a point.
No, bisect. Tell us.
It means it goes through at half. Okay.
Yes, that I'm not arguing with you, but how does that help me? All right.
It means that EC goes through at BD's half.
What?
It means BC and CD are equal.
Yeah, guys, that's what everybody needs to know. All right, they're telling you that AC bisects BD. When something is bisected, it's just cut in half. All right, which means what is true about those 2 statements, BC and CD? They're congruent. That's all you need to know. Right. So once again, statement number 2, we should be able to say BC is congruent to what? CD, and that is because, yes, thank you, definition of bisect. All right, now I can come up here and I can just say 3 tick marks. All right. And now I can, yeah, guys, you hear all these stories about how complicated this is. And I just don't understand why everyone thinks proofs are so hard. All right. And then you would say what? Be careful. Side, side, side. All right, that's it. All right, anybody have any questions with that? All right. All right, anybody? I told you, very basic, very easy. All right, let's see if there's something more challenging. All right, now I gave you graph paper. If you need some more graph paper, we can do that, but we're definitely gonna have to use some graph paper here. Yeah. Now, I would like everyone to plot these triangles, MNO and QRS. Okay, there's one right up there. All right, the question is, are those congruent triangles? Now, I don't really think at this stage of the game, there's any way to measure the angles. Do we agree? Right, since we can't measure the angles, what we're going to do is have to find the distances. All right, now, again, the distance formula is used a bunch. All right, so once you get that done, all right, what we're going to do is we'll start with the one on the left. All right, and this is where we're getting practice with our mental math, and we're getting practice with our breaking down square roots and all that kind of stuff that you will be seeing on standardized tests. All right, that you're expected to know. All right, so first thing is, can you remember what the distance formula is? Distance equals x2. What was it? Minus x1. Then what did I do with those? Squared. And then it was plus y2 minus y1 squared. And then I did what? I took the square root of that. All right, so please write that down if you forgot. The other thing we look at is we can say that this right here is also just the Pythagorean theorem. Right, does everybody agree with me? It's just the Pythagorean theorem. So instead of doing that, all right, since we drew it out, I'm just going to come down here and I would like to just show you how I would look at this and say RQ. All right, come on, guys. This is where I need your help. RQ is simply the square root. Now, again, if you're not sure, remember we drew this as a right triangle. So everybody with me on that? Everybody see that right triangle? So this is 3 and this is 3. Agreed? So 3 squared is what? 3 squared is what? 9 plus 9. So RQ is the square root of 18, but we know the square root of 18 is just what?
3.
3 radical 2. Agreed?
How did you get 18?
Did you have trouble with 9 plus 9?
Well, where did you get 9 from?
Did we not say Pythagorean theorem? A squared plus b squared equals c squared. This is a right triangle. Do you remember the Pythagorean theorem? Right triangles. A squared plus b squared equals c squared.
Okay.
All right. the most famous theorem. A squared plus B squared equals C squared. So we're trying to make all of them right triangles. Anybody have any trouble breaking down 18? All right, so now we're going to check out QS. QS. Everybody can look at that and say, all right, QS. We're drawing it out here and here. What is that? Somebody said radical 17. Can anybody else see that's radical 17? What's this length right here? 1. What's this length? The vertical length? 4. So everybody agreeing now? 1 squared plus 4 squared. Everybody agreeing now that's 17?
Yeah.
All right. Can I break down square root of 17? No. So now we have RS. RS. What does that look like?
Radical 17.
Anybody else have any problems calling that radical 17? Anybody? All right, so now we have radical 17, and 3 radical 2. So hopefully everything over here matches up with that. So
Yeah, it does.
I'm going to do OM is equal to square root of what? Come on, don't write 17 if you don't know it's 17. That's what I'm having trouble with some of you. All right, you just write down what I'm writing down and think you're okay. You're not okay if you can't see it's square root of 17. I don't mind showing you again. All right, I don't mind explaining a squared plus b squared equals c squared again. All right, but don't just sit there and write down the numbers if you don't see it. So we all agreeing OM is the square root of 17. Yes. All right. What about MN? Somebody said 3 radical 2. Don't take their word for it. All right. Do I need to draw it? This way for those of you guys who need to draw. And then the other one I'm missing now is what? ON, right? And that is what? Radical 17. So are the triangles congruent? By what? Side, side, side. That's how simple. Very easy. Go ahead.
Instead of like, but instead of like finding or doing these different things, like when you just like find this, like when you add the right triangle, could you just find the distance of it and see the match that the other triangle is?
I don't know what you mean by looking.
Like, cause it like for RQ it's 3 and 3 for the right triangle.
Oh yeah, you technically, yeah. If you knew that was 3 and 3 and that's 1 and 4, of course, those are the same. Right. But generally you would have to say the sides are congruent, right? You know what I mean?
Yeah.
All right. So does everybody agree? That's really not that hard. All right. The distance formula 6 times. All right. But with your great mental math ability, it's really not that difficult. All right. So let's scroll down the page. Let's see what's next. So same thing with 9. Let's go beyond that. Same thing with 10. You can do that for homework. All right. Let's take a look now at number 12. And really what I need to do is I really need to cut this out right here. Bless you. The book was too nice. All right, so let's do this. Let's pretend like we didn't see that. All right, draw your triangle now. All right. All right, let's see what's going on here. All right, so I didn't mark anything or I erased what was on the figure because I really don't want you to, you know, I really don't want you to assume that it's going to be marked because I can tell you I am not going to mark it. Let's try to pull it up. All right, give me 1 second. I'll let you help me. All right, so I'm just going to pull this and just. All right, there we go. We can see it. Oh, well. Maybe not. Oh, I know what I can do. Copy. Not paste. No, it should go. Oh, that's true. Thank you. Now I can just put it in there. All right, now we don't have to look at what we wrote. All right, so I really would prefer you write or tell me if BD is perpendicular to AC, that has meaning. All right, so what does that mean? What? They intersect at a right angle, right? So that means that you could now tell me that ADB and CDB are what? No. You don't say they're congruent based off of. No. No, we're doing perpendicular first. Why is ADB and CDB right angles? Definition of perpendicular. All right, it says BD is perpendicular to AC. Lines that are perpendicular form what? Right angles. All right, so you're going to say that angle ADB and angle CDB are what? Right angles. And they are right angles because what? Thank you very much. Definition of perpendicular. You are correct. All right. 2, definition of perpendicular. All right. Lines are perpendicular, meet at right angles. All right. So now what is true now about angle ADB and CDB? They are congruent. So now you can say that angle ADB is congruent to angle CDB. And that's because why? All right angles are congruent. All right angles are congruent. Okay. Come on, someone else join in. Please, the same people, same boring people, give me all the answers. All right. You're not boring. You tell me. Is not what I'm looking for. Well, let's call it congruent, please. AD is congruent to DC. Why is that true?
DB bisects AC.
Right. So we would say the definition of bisect. All right. So now I'm going to mark this congruent to this. All right. Now someone else who's not boring. You're boring.
Wait, hold on, I won't be boring to put this on.
Tell me.
And then, so it would just be ADB, triangle ADB.
Not yet. I only have 2 parts. Are you boring? All right. What? BD is congruent to BD. Remember, you always need 3 parts. You always need 3 parts. So now we say BD is congruent to BD. And that, of course, is the what?
Flex.
Yes, we are reflexive property. All right, now go ahead.
There's ADB.
What about AD?
triangle,
Thank you.
ADB to triangle C.
What are we trying to prove? I forgot.
Oh, you got triangle. The triangle, or triangle.
So now, because I covered it up here, I'll remove it now, maybe. All right, yeah, so we're now, what you're proving has to be written. All right, so even though you could say the triangles are congruent, maybe by saying BDA, you want to write down what they say to prove exactly. Is everybody good with me? Everybody understand that, right? So we're just gonna go ahead, just a minute, I'll help you with. Let me just go ahead and grab this. So this, I'm just gonna put down here. Right. And, all right, we know that's true because why? What is it? Side, angle, side. All right, I'm supposed to care, but guess what? All right, anybody have any issues with that? What?
So this isn't a big issue, it's just a little one, but when we say BD is congruent to BD, I thought yesterday you said we were supposed to say BD is congruent to DB.
You know, that is a pretty good thought, but that was when the triangles were rotated. In this case, they are not rotated. ADB is definitely congruent to CDB. All right. So everybody understand, I for the life of me, and I'm not joking, everybody thinks this is so hard. And I just don't get it. Or I don't understand why that is so impossible. All right, you're learning to follow steps. All right, you're learning to say, okay, I think this is true, but I'm not allowed to say it's true. I have to show that it's true. So you have to write down the steps to prove it. Anybody have any issues with that? All right, anybody? All right, so now let's briefly look at 13. All right, no, we don't do paragraph proofs. We always do 2-column proofs. So that's going to be your 13, 14, and 15. All right, so your homework is, I'll just give you a little break. You have to do 9. All right, just 3, or you have to prove, using the distance formula. And then you have to prove those triangles are congruent. And then you have to prove those angles are congruent. And whenever they give you angles are congruent, you're going to have to do what? Whenever you have to prove, yes, whenever you're trying to prove angles congruent or sides congruent, that means you're going to use CPCTC. Okay, so I want everybody to try 13, 14, and 15. All right, 13, 14, and 15. Anybody have any questions? All right, equilateral. What does equilateral mean? All sides are equal. Exactly. All right, just refreshing your memory on that. Anybody have any questions? All right. All right. If you need a piece of graph paper, go help yourself to the graph paper. Good job for today. Yeah, for an equilateral triangle, right?